Hello, this is season 2, episode 2, Algos and Ten with Jason Liu. Definitely, y'all been wondering if I could do any coding, and the answer is absolutely. I can do coding, guys. I could do it so well. I'm going to show you guys my entire GitHub repo for that coding in Jupyter Notebook. So if you're not familiar with Jupyter Notebook, it's basically interactive Python, like Google Docs, like interactive Python platform to be able to do some coding, and it's very, very fast. You have to worry about the PyCharm, like install modules and stuff. You don't have to worry about like the IDE, like not showing graphics. It's a beautiful thing for data scientists, the Jupyter Notebook. Also, it's for free. You don't have to pay any money, and you can just, pip install it and enjoy using it. It's been essential to my Northeastern data science concentration with the Jupyter Notebook. And even with the Dell work, it's been essential for like understanding different type of graphs and stuff with the mainframes. So yeah, this is obviously very important to understand Jupyter Notebook. Without further ado, I'm going to show you guys now the slide deck for the Algos in 10. And after I show the slide deck, I will then go for the coding solution, and then we'll talk about episode 3, which is a very special tribute to a Netflix movie that I truly love as a believer in something that's really awesome. So yeah, here is my, I'll share my screen. Present. Beautiful. So here we go. Algos in 10 season 2, episode 2. So as you can see, we got some topics. We got the TensorFlow, which I mentioned before with episode 1. But let's do a little quick coding demo with what the coding is generally doing. We'll do the run code with the notebook, actually show that it works. It's not like me BSing it or copying from Stack Overflow. And then finally, episode 3. So a nice little quick trivia question. What is the correct way to import a statement in Python? Give you guys a few minutes to think about it. All right, the answer is from start import package. So what's TensorFlow? If you look at the website for TensorFlow, it is a very beautiful website. So I'll click on it and we'll take a look at it. So TensorFlow is a machine learning programming website, which is very popular in data science, as shown in, like, for example, I don't know, a few new YouTubers in CS like Nick White and Kevin Norton Jr. Congrats on your offers, by the way, guys. Shout out to those guys. It's also really beautiful in terms of like understanding machine learning. It's like machine learning bread and butter using TensorFlow. It's very easy model building, robust machine learning production, and a powerful experimentation for research. In season 1, I never really used any like library functions because I never had to do any coding. But now with coding, it's a different story. So let me go back to my slide deck as we talk about TensorFlow. So, sorry. TensorFlow is basically end-to-end open source machine learning platform. Let me break it down word by word. End-to-end with both backend and front end. You know, in every application, there's like a front end to make it client-facing and a backend to like run the application, as they do with many web designs, web developments. It's open source. Anybody with proper permissions can edit, make changes, play around with it to existing library projects. We can definitely download examples if we want to. We will be using an example for the final part of the problem solving with computers. And of course, machine learning, the computational science of method of data analysis that automates every analytical model building. I always cite my sources, so here's a beautiful source to talk about machine learning. As a refresher from episode 1. So we have the Space Jam, LeBron. LeBron's falling to Toon World. He wants to save his son from Goon Squad. He picks you from first pick of Algos in 10 season 1 viewers, picks you, okay? So that's all that from episode 1. Then we also talk about the most optimal lineup versus Goon Squad by 3 ways. Dynamic programming, which I actually show you guys a LeetCode style solution for dynamic programming on my notebook. Neural networks, I use a library called PyTorch for that. And backprop with the least weighted input output neural net nodes. So I use like a graph algorithm for that. Don't worry if you don't understand all this gibberish I'm talking about right now. It's all a build up to like the actual coding. Just sit tight. So for part A, we have the dynamic programming review, beat my boy Troy in gaming. So now we'll code a solution using some Python programming to solve the episode 1 dynamic programming problem. with some test cases using TDD, test-driven development with Python assert. Don't worry about the code syntax, just understand the underlying algorithmic solution. And of course, if you do leak code for getting those good old FANG 4500 companies, you'll understand what I'm talking about. So without further ado, I'm going to show you guys the solution code for this. So go back to my screen. Here you go. Here it is, my coding solution for Space Jam. So as you can see here, don't worry if my recording is blocking the screen. This is just a recording. I'll show the actual solution in the description for the episode. You can play it on however you want. So here's the problem 1 coding solution for dynamic programming. To review that, we have the problem statement. LeBron wants to first pick some NBA 2K packs for matchup. So given a series of packs P1 to Pn with some boosters and some deniers, you want to basically help LeBron find the maximum NBA 2K packs. So if you remember from episode 1, we made like a Bellman-Ford equation for dynamic programming. We're now putting that into code. This is sort of like an optimized solution. Ordinarily, I would not expect anything like this for first try for interview. Like if you get this thing, you're getting to like Facebook and Amazon, Google easily. This is like something that took me a week to figure out. Hence why I do bi-weekly breaks between the episodes. Not only for Dell reason, but also for the fact that these take so dang long to make. Like this whole thing took me like a week to figure out. So if you can figure this out in a week, kudos to you. You're already way ahead of the curve. Anyway, here's the dynamic programming solution. We got parameters, boosters, deniers, indices, and K. K is, of course, the total number of packs we have per selection. We set packs as in the list. Base case is very simple. No boosters, less deniers, return 0. No deniers, less boosters, return 0. This is a nice, interesting base case I tried to abstract away. Since I obviously play NBA 2K, you can't select negative NT packs, boosters, and deniers unless you're like hacked it or something. So you return none. In addition, you have a recursive case for dynamic programming. So you have a recursive case in a for loop. So you return the maximum of either of the boosters plus index, deniers minus index, index comma K. You also got the dynamic programming for boosters, deniers, and 0, and then boosters, deniers, and 1. As you know from episode 1, this is just the coded version of our Bellman equation. If you don't remember that, please review episode 1. And now I'm talking about the TDD, test-driven development with Python. So as you can see, I make a very simple TDD testing style. This is a beautiful website from Rubik's Code. I don't tend to use Stack Overflow because some of the answers are very trolly. So I'd rather use something that's more legit, like an actual blog website. That's something I learned the hard way in my master's in co-op work at Northeastern. So use the right portions of code, unless you want to spend all night debugging it. Not recommended. Anyway, I used a unit test, library. I make a very cool class for the testing. This is not really necessary, but it's good to have a setup code for Detroit and Dynamic Programming library. And of course, I have 3 test cases. The test case where I have basically nothing and should return 0. If I have basically only no boosters and only deniers, return 0. Other way around down here. If I have no deniers, only boosters, I should return 0. And of course, if it's all negative, like in this case, it will definitely say cannot select empty packs from negative boosters and deniers. One issue with something like this is that you have to be careful if the test cases are redundant. So that's why you have to be very careful with TDD. What I tend to do is the following. So I'm going to use a little bit of the whiteboard now here, actually. Annotation. So I'm going to use a little bit of annotation here now. Test case pro tip. Make sure they're not redundant. That's the first number 1 rule of TDD. If you redundantly code your test, you're going to not only fail leak code test cases, you're also going to really struggle debugging your code. And that's going to be an exercise in debugging hell, basically. In addition, learn to actually keep track of sanity checks. So for example, even if you don't play NBA 2K, like in just real world coins, you don't see them being negative, right? You don't see coins being negative in value. You don't see coins being negative in weight or in any type of dimension. So that's the reason why you don't want to have negative coins. I'll now clear all that. So I could go back to my screen. Sorry. Exit out. Okay, cool. So that is basically my dynamic programming solution. And of course, it passed all test cases. Beautiful. This is not going to be enough for a leak code problem. You have way more test cases, but this is just illustration of how TDD would work. So getting back to my slide deck, problem 2. Yeah, problem 2. So problem 2 was just a neural net review with regards to PyTorch. Just a quick intro to PyTorch. It is essentially TensorFlow's baby, or TensorFlow's son, in that you basically don't have to worry about keras or any advanced neural network stuff. Just have to remember 3 things: convolution, weights, and perceptrons. This is a beautiful library for telling how PyTorch basically works. We'll take a look at it right now. Sorry, we'll take a look at it. PyTorch took me a while to figure out because you can see it's so dang complicated. There's just too many pictures. So we're going to move to the code instead. This is the example I was using to illustrate PyTorch. You have 1 input image channel, 6 output channels, 5x5 square convolution. I'm going to annotate again here. So essentially, think of a channel as like a big box. It's a big box. And inside each other box, you have like smaller boxes in here. And within each of the smaller boxes, you have something called an input-output channel. So the channel will basically tell you whether your convolution works or does not work. Yeah, if it works or does not work. So input-output channel. The reason why this convolution can get tricky to use is because of the following. You have something called an affine operation, which if you remember from basic algebra, it's y equals mx plus b. In this case, wx plus b. W is your weighted slope for gradient descent. So you see, like what Stakami said, math does help even in the real world. Definitely remember your algebra, guys. And of course, you have a 5x5 image dimension here. And this is a really cool function called forward. You have something called max pooling, which is like the maximum amount of like convolution you can get in the neural network. And since the size is square, which is obviously prerequisite for like a neural network convolution, you can specify with a single number and you can find and stuff. So you can see the output is basically not exactly an output of numbers, but an output of an object. There's something called call by reference versus call by value. Trivia question number 2, what's the difference between the 2 of them? If you don't remember, Google it. That's what my motto has been all summer. If you don't remember, Google it. So call by reference versus call by value. You can see this is like my behind the scenes work, what I do every single day as a computer scientist. Just search stuff on Google. So call by value, a copy of variable is passed, whereas call by reference, a variable itself is passed. So obviously you got a call by reference in this case, a variable object. So back to the actual code, and I'll actually delete the annotations, clear, because I don't want to have this being distracting. Select, yeah. I'm going to have now part B coding. So as you can see, I installed PyTorch using some cool looking sys executables. I basically did the same thing. I replaced the values with my own from episode 1, 0.6, 0.7, 0.8, 0.5, 0.4, 0.3 from the 3 neural nets we have shown in episode 1. The only trouble is since convolution is a base 10 thing, we have to times it by 10. So we did that. And you can see in the results, we get the same exact thing, a convolution 1, convolution 2. And FC stands for basically a function in neural networks. You don't have to understand all what the parameters say, just understand this returns an object, not a value. So you can see already machine learning programming is harder to debug because you have to debug objects, not values. Of course, then to check for the parameters, we basically determine the torch.size. So torch.size is a PyTorch function that allows you to basically get a list of like the best neural network values. And of course, we convert that to a list using some list conversions. And then there's the function I made, which is like determine if it's within the threshold bound. Remember from episode 1, we have a decision tree classifier. We say win or not win, the game with LeBron's Space Jam team. If you win, you basically get above 0.5 probability of winning. So we basically did like this. If the 2 times b plus d minus I minus j from episode 1 formula is less than 5, you say it's not threshold bound, otherwise it is threshold bound. Since I basically hard-coded the values, this has to be threshold bound. But you'd be surprised, Python can do some very crazy things with libraries. As I mentioned, yeah, so it's basically a yes-no decision tree classifier with threshold bound of 0.5. That's like the easiest form of decision trees. If there's anything else, it's not a very balanced tree. You'll learn more about trees in a later episode. So back to part C of our programming now. So the galaxy opal perceptron calculation, as you can see, I lovingly put the table here and to calculate perceptron. So remember how long we spent from from episode 1, just trying to calculate the perceptron and add this up in times 0.5? That took a lot of brain power. And generally, I would not recommend doing anything more than like maybe 10 of these. With Python though, and PyTorch, oh, this is super simple now. We can just literally get a dictionary for all this. We can convert them to a list. I like to use dictionary because I want to know who actually has what weight. Like I can't say LeBron only has weight 8 or Grandma has weight 25. That's not going to make the Toon Squad have good chemistry, like in the NBA. Oh, speaking of which, shout out to the Phoenix Suns making the NBA Finals. Proud of you, Chris Paul. And shout out to the Bucks as well. I wish the same could be said for the Celtics. Yeah. And then, of course, we calculate the perceptron score manually. So if any of the weights are basically 0 or less than 0, you can't calculate negative weights for perceptron score, which is embarrassing, but that's part of life. Otherwise, we do some crazy stuff with random numbers. You don't have to worry about too much about random numbers here. Just assume you have basically 8 slots of like each member of the Toon Squad. Remember from episode 1, we had basically only 8 members, because guess why? You have another member in case anybody gets injured as like a replacement. It's better to always have a backup. Then you basically have the sigmoid function, which is a fancy function for determining the weights of the pre-predicted value. And if you know anything from machine learning, predictive and actual values are super important. They have to call the traj or the target value, which basically determine the ones. So this is not my original code. This is actually sort of low-key modified from something called programmersthought.com. You can look at it very carefully by yourself, but I'm just going to go over my solution. Here's the fun part. Backprop. This is where you calculate the backprop. It may look very simple, but behind the scenes, you have to be very careful here. What is W? What is B? You don't want to get them confused. W is the weight of each perceptron, which is, of course, the numbers here. B is called the perceptron base values. That's something you have to calculate with gradient descent, as they show over here in this. B equals B minus LR times B dot grad. Grad is gradient descent. And this is obtained by backprop. And of course, we determine finally the sum of list weights times 0.5 because we get 51.5. Yeah, so that's great. As you can see, there's another return of an object value. You got some solid weights. And this is just a function in Python about finding the gradient descent and at 51.5. All right, so just long story short, whenever you're coding Python machine learning, please, please, please use libraries. Do not code this by yourself. It is not worth it. It's going to take too long. You're going to probably be done with the summer by the time you finish coding it. It's not worth it. I want to enjoy my life for July 4th. So yes, here's part D. So wrapping up the whole thing. We finally now basically form a super team of Python libraries. We have PyTorch, TensorFlow, and Python Network to solve part D. So basically then try to determine what's the best optimal starting lineup to beat the Goon Squad. And spoiler for the movie, there'll be a special someone in that movie to help LeBron out. So one thing I noticed a lot, even for myself in my BU undergrad Northeastern years, some people just like to copy off stuff from LeetCode and just say, oh, it's my solution. Not enough, man. You're going to get cut from the team. You need to add comments. Like comments are literally explaining what your code is doing. Even something as simple as this one, for I in range 10, print LeBron James, which is like a BU, like a 101, like 111 course thing. It literally says this module will print out the statement LeBron James 10 times consecutively. If you don't do that, you're going to have your person who's going to read your codes have no idea what the heck is going on, and you're going to have a really hard time understanding. So as a quick demonstration, my part D is way more difficult and way more involved, but it is definitely going to show you comments. And as a reminder, here's the lovely picture screenshotted from episode 1 about what type of neural net we were drawing. So just as a refresher. And of course, there's a caveat. Don't worry, we have not covered min cut max flow. That's going to be next episode with another problem. Just think of it right now as an abstraction from convolutional neural networks to graph algorithm, which means you basically reduce the complexity of a problem from like a crazy neural net to now a simple within P polynomial time graph algorithm. P versus NP is a very complicated concept that you need to understand if you truly understand algorithms. That's going to be like near the end of the season. Yep, so basically all this to find the least weighted input-output neural net paths for problem D. As you can see, this is one of many solutions. Given backpropagation has error margins. So it doesn't matter what the solution is, just understand what the code is saying. That's all. So here's the code. We install Networks X, we install TensorFlow, which you can see took a long, long time, like 5 minutes to install. I basically gamecasted NBA while I was waiting for that. Here's the coding solution. As you can see, I make some very beautiful comments, some very colorful comments. Hey, what's up, Doc? From like Bugs Bunny. But you can see I'm basically making like a graph here from like source to all the different nodes of the different players. And then of course, since we want to win the game, the source node is all win, the sync nodes are win game, win game, win game with, either win or lose the game. So capacity is 0.5. We print out the graph. And here's a bonus for those more who are actually good at like understanding abstraction. This is something you can answer in the comments as well if you're really interested. What happens if we add in the Willie E. Coyote, who has like, from the trailer, multiple copies of himself? How would you be able to solve that without having to like run 100 times this function? The answer is use something called bipartition graph. Like basically split each and every copy of Willie E. Coyote into 2 graphs. That's a more advanced form of coding. So I'm not going to show it here today, but if you want for like a behind the scenes, we can do that. Finally, we have some calculated metrics, the cut value partition, reachable, non-reachable nodes, which is very simple, just whether can you even get to a path or not. Then you get the optimal starting lineup. And because we want to read English, not code, I decided to use list comprehension to make it easy to read. And then of course, the moment we all been waiting for, use Keras and TensorFlow. Use a baby like data set as assistance. The reason why we're using this data set, the min and NIST from TensorFlow, is because I want to make sure the Keras has a good model fit. And then once we fitted all the model, we get the training and testing data from machine learning, and we did all that good stuff. We then finally get to say who wins the game. So now instead of me blabbing on all the time, let's actually run each piece by piece, the code. So I'm going to now share a couple of pro tips for testing. So as I mentioned before, pro tip for testing, make sure all your test cases not only pass, as my professor in Northeastern said, like passing is only 50% or half the battle. You have to make sure they make sense logically, which means, for example, if somebody doesn't know what even backprop means, they at least could tell them, oh, you can't have a negative weight. So for example, don't test backprop with negative weights unless specifically asked to, which I have not yet seen a case of doing that. So you can see, as I mentioned in the Space Jam terms, so Granny wasn't going old school after all. Testing is king. That's right, King James. And of course, one more thing, very importantly, before I run the code, be like Mike. That's a great analogy, MBA encoding style. So you want to be like Mike. You want to make sure your solution makes sense. Intuitively think of ways to improve it. Keep each solution subproblem simple. As you can see, my solutions are like maybe what? Like 20 lines of code total. If you have anything past 50, you're making this way too long and nobody's going to understand what the heck you're talking about. And finally, very, very important, examine any ways to improve runtime for both time and space. Just like Michael Jordan, you want to be the GOAT of algorithm solving. So you want to like keep on improving your runtime much more than before. Like for example, I could have used like maybe a try or something for the graph for the network. And now I'm going to run the code actually all together. All in one, 一口气 is in Chinese. So the first thing I'm going to do is run this, then run this, then run this. This is all going to just be a bunch of, running. Run the dynamic programming code, get the test cases, all the tests passed. Very nice. Run this. I installed PyTorch already. That's not going to be a problem. Ignore the warnings unless you actually have to upgrade pip, because sometimes it'll mess with the Python Jupyter Notebook. Then you have coding, more coding, blah, blah, blah. It passes the boundary, you're good. Then you have coding solution, blah, blah, it goes to 51.5 perfectly. And finally, more coding solutions in general. So yeah, let me continue the code. So you can see the code is continuing running the TensorFlow and everything. Once again, you see the pip warning over here, and you have now basic coding solution for part D, which means you have the import statements of NetworkX, NumPy, TensorFlow, and this is getting a little bit boring, so I'm gonna show you now the solution. So I keep on running this. It'll take a while, but it eventually says the best chance of winning is 50%. And there we go, end of the game, Tune Squad won, and I basically showed my solution from season 2, episode 1. Applied backprop to the neural network for the top 2 starters, including LeBron. As you can see here, the starters, basically very nicely made over here in a nice list, like an actual NBA list, not some sort of gibberish over here. Yeah, for top 2 starters, including LeBron, and then choose the minimum of the remaining weights from up to T-1 starters, where T is the total number of players, starter bench included for the Toon Squad team. So enjoy the movie, July 16th, like and subscribe. I'm not done yet. So as you can see, I did mention episode 3, right? I won't tell you what it is. You'll need to do a little guessing game. But we'll begin with something called confusion matrices, which is just talking about, true and false values in 4 ways. True positive, false positive, true negative, false negative. There's, of course, the beautiful Bailey Madison and the handsome Kevin Quinn. It's already a very major hint what this is going to be about. It's a Netflix classic. So if you don't understand it, I'm sorry, man or woman. You need to get on Netflix and socials more. So yeah, that's it, folks. Episode 3 will be 2 weeks from now, and make sure you can subscribe and like. So just one more thing before we wrap up. I do have something in Python called an image function. So this is a very helpful function for basically being able to display the Python image-wise. And also, as you can see, this is something you can repeat. So one beautiful part about Jupyter Notebooks, you can basically repeat Python notebooks however you like. So you don't have to worry about self-plagiarism or anything like that. You could just make all the notebook go well. And just make sure you don't get plagiarism. You can always, cite your sources with links and stuff. So yeah, that is it. This is episode 2, season 2, Algos with Jason Liu. And of course, enjoy the Space Jam movie if you're watching it next Friday. And hashtag be like Mike. Thank you very much.